Good morning, folks. Welcome to the radio. I'm gonna speak about an amazing project I've been working with for a couple of years, almost full-time since a year back. And this is using the technologies we've been using for telephony for a long time for a completely different application. If you go back in history, this is where people like me, the old guys, have been for a long time. The convergence, going from telecom technology to datacom technology. This doesn't only change the technology, it changes business models and has affected us all. Everything in telco has become data. Packets on a network, right? This is what we've been working with, what you are working with. Taking over a specialized infrastructure made by specialized companies with strange Swedish names and other foreign names, and making it applications running on standard computers, right? This is a revolution for people who used to work in the old history. But for us, this is just what we've been doing. So everything will be IP. Everything is digital. This is not news for you, not news for me. But in industry after industry, this is becoming news. People right now are working a lot with IoT, the Internet of Things. And they try to create other ways to communicate that isn't IP, other networks that isn't standardized, because they want to work with old business models. Well, we took over Datacom. Anyone here running DECnet? No. We took over telecom. We're taking industry by industry. IoT will, of course, be IP, will be packets, will be digital everywhere. And in this transition, things are becoming commodities. Stuff that was highly specialized, high margin business, with cool salespeople, with funny giveaways and credit cards that paid for fancy dinners and parties. That stuff is now in mail order for a few bucks from China. Delivery free of charge. Things that used to be specialized become commodities. And this is something we've seen all the time, right? It keeps happening. So this, of course, affects professional radio broadcast big time. Here you see an example of a new piece of equipment that we used in a live radio show a week ago. Anyone recognizing the fancy specialized hardware? Right? I can sell this to you for 20,000 euros. It's a Raspberry Pi. And a standard mail order USB audio chip, right? So I've been working with VoIP for a long time, as Daniel said, and reminded me of. Yeah, right. Where's my wheelchair? Can I borrow yours, James? Thanks. I've been in this business for a while. I started with VoIP and had all these visions that this is not telephony. This is a lot of real-time communication. We have chat, we have video, we have presence, we have all of this, and we're gonna make a beautiful world. And this is where I ended up. Phone numbers. ISDN functions over IP. We got to have this, we got to have that. All these functions that no one cares about anymore. This is what I've been doing a lot of my time, and that's why I'm so happy to work with other things. But I just have to apologize now for the next picture. If this offends anyone anonymous in the audience named Matt who made a life out of ISDN and SS7, I apologize and I will make it up to you. But SIP is not ISDN over IP. I'm sorry. Remember that. Swedish Radio is, of course, a state-owned public company, right? We're operating a lot of channels both on air and on the internet. We've been on a long journey. And we have a vision in the radio. We need to broadcast live when it happens, where it happens. We need to get journalists out of the buildings, out of the safe environment of the studio, and broadcast live. We even have a vision of moving the studio out of the studio, having portable equipment so we can mix and produce radio outside of the radio house. We're members of the EBU, the European Broadcast Union, and many of you know, the people from Europe, that tonight the EBU is starting the annual Crazy Song Contest, right? That's the EBU. Another part of the EBU is creating standards for radio and television. EBU have created a standard called ASIP with C. This is audio contributions over IP, basically SIP adopted for live radio broadcast. Contributions from various offices and outside of the radio houses. This is basically IETF stuff. I mean, SIP, RTP, SDP, various codecs, Opus, of course, MPEG-2 and others. Compressed audio like GSM is a no-no. We need high quality audio. If we have this amount of bandwidth, we want to fill it with broadcast quality audio. We're filling all our pipes to a maximum. And that's a big difference from what we're doing in the ISDN over IP market. We used to have in the radio various radio systems, HF radio, when we went live. And that backpack required someone that had done a lot of training because it's really, really, really heavy. And normally you had the guy wearing this, and then you had the journalist that couldn't wear this, and some other people in a production. The idea was to go onto the ISDN network as soon as possible and then get into the matrix where we do all the live broadcast, right? The matrix is where we connect to the broadcast radio transmitters and others. We also had a network to sports arenas and music, concert halls and other places with ISDN, leased ISDN lines connecting to the radio. Today, this is the most used equipment, a backpack. Running IP. And we connect over mobile networks or Wi-Fi with IP and SIP directly into the radio network connecting to the matrix. Imagine the change. The journalist itself, he or she takes the backpack, runs out on the town. There's a fun story here. When I was down in southern Sweden in one of our radio offices working, we looked at the backpack, discussed various things in it. We have batteries, we have SIM card devices and other stuff. And a journalist came up and said, well, I booked that, I'm going out live. And we said, okay, fine, it's yours. And she looked at it and said, well, I can't use that, and pointed to the mic hanging, this one. And we looked at her and said, what? Can't use that, you need training or? No. I'm gonna drive the car while sending. She was going on air in a radio show while driving a car. So of course she wanted a headset, so we fixed a headset for her. My friend Olle at the radio later told me about sending radio from cars just a few years ago. That involved 2 cars and potentially a helicopter, because you needed 1 car with a journalist and the guy you interviewed and a driver and a technician that had a radio to the second car where you had a studio staff that may have broadcasted live to a helicopter with a radio link. Now, for her, it was natural that she should be able to drive and send radio at the same time. That's how we change production. With new innovation, we change the content of the shows. And we're heading for IP everywhere. Right now, the matrix is a combination of various proprietary and open standards, but the new EBU standards is promoting RTP, IP, and SIP in there, but not really the way you're using it, because here we have strict timing. We base the timing on PTP, a timing protocol with more precision than NTP, and we have extremely small payloads of the RTP packets. 20 milliseconds is an eternity in the matrix. So this is our infrastructure. We have Kamailio in the core. We have mobile production, and we call the devices, funny enough, this is old radio slang. The device is called a codec. That implements a lot of codecs. Yeah, this is confusing. But we have mobile codecs, we have iPhone apps, we have studio equipment, we have the external sites, the music concert halls, the sports arenas, and we have connections to the phone system for telephone interviews. We've developed in-house something called the Codec Call Monitor, the CCM, and all of this connects to the broadcast matrix where we have the FM radio and the internet streaming. The CCM is the application that actually shows everyone in production, from engineers to producers to our master control room, what's going on, what's live right now. And we can see where they're based, what kind of connection they're using. We can select on a number of terms and see the number of calls. So for me, with many years of VoIP, there's a few very important lessons to be learned here. Signaling and charging is not really important. Audio is important. As long as we have audio, we're live. If signaling breaks down, who cares? We're live, right? So audio is important. And this gave me a bit of a trouble using, for instance, the Kamailio dialogue module that breaks the call as soon as we have no signaling. Oops. Didn't make people happy when I broke calls, broke live broadcasts. So not going to happen again. We need to make audio great again. We need more opus in all our networks. Focus on the audio, folks, because people will be happy. Use opus. And in the radio, we focus on the bits. For audio, we want as much as possible a clean 24-bit path, 24-bit samples, no transcoding if possible. And of course, we're using IPv6. With all the mobile applications, the carrier switch IPv4 to a carrier-grade NAT. And if you're using one of those dongles with Wi-Fi, you have 2 NATs on IPv4. Oh, sweet! But the IPv6 path, the audio flows directly from the device straight into our audio matrix, like a dream. So 128-bit networking, folks, IPv6, that's the shit, man. That's what you want to do. So audio infrastructure, transparent, 24-bit sampling, IPv6, no NAT, no carrier grade NAT. We're happy. We have less latency problems, less audio problems on IPv6. When building this infrastructure, very early on, the Swedish Radio decided not to build every single piece by themselves and try to get commodity software, to get software open source that was available and could be modified for their use. They're also working with vendors, getting them to implement the ASIP standards to connect. So very early on, I discovered what was going on because a lot of people from the Swedish Radio came to my Kamailio trainings, the SIP masterclasses, and they came with very interesting equipment. They couldn't really talk with any IP phone in the classroom, but they said, oh, this is my SIP phone. And the cost of that SIP phone compared with the SNOMs I had was a bit different because this was radio carrier class equipment, right? So we're using Kamailio in the core. We have plenty of Kamailio servers handling all of this, and it works great, of course. We're using HTTP connections to the CCM to tell the CCM what's going on. We're using the dialog module to keep track of what's going on, and a lot of other things. We're using BarrySIP, a great SIP software, command line oriented. We made our user interface to that, adopted to journalists. In the backpack, we have a Raspberry Pi running BarrySIP with Opus. It's way cool, good software. Asterisk we use for integrating with the phone system only, because Asterisk doesn't have all the properties we need, and we really don't need PBX functionality. Asterisk swallows the RTP and changes the media path. If we can avoid changing media path, we want to avoid that. But it's great for the PSTN stuff. Coming soon to our network is Janus. We are going to start experimenting with replacing the phone system for interviewing people outside of our houses with WebRTC sessions. We want to do interviews with people over IP with great audio compared with the phone network. Every single week, people from all over the radio contact me and say, well, we have a problem here. We did a telephone call and interview, and the quality was this bad, and can we fix that? I said, well, if you vote for the telephone party that will make a monopoly of the telephone system again, and we invest billions and billions in a system no one uses, yeah, we can fix that. Otherwise, we have to find other ways. And the other way is Janus and WebRTC. We're running Homer SIP capture and test, and this is dangerous because we haven't got proper time to get it all installed on all the servers. And while testing, people have started using it in production because they love it. It makes signaling great again, and it's just fantastic. We're using FreeBSD and Debian Linux, and we're running over 2,500 hours of live radio every single month on this platform in a small country like Sweden. We have the fixed codecs in all our radio offices around Sweden, and we have the backpacks, we have satellite dishes on cars, small cars, model Ford Fiesta. You're thinking OB vans, but our OB vans are small, 1 or 2 people cars, but they still have satellite dishes and a rack, a 19-inch rack in the back with professional equipment and routers and VPNs and stuff. So open source works really, really well for the radio broadcast industry. And again, sorry, Matt, anonymous Matt, SIP is not ISDN over IP. This is the stuff you can do with SIP if you use it properly. Not phone calls, but live radio. So where are we going? Well, these are exciting times for me. We've been doing a lot of work behind the scenes for a long time. We want to share what we are doing because we're building on the shoulder of giants. We're building a lot of open source. And we want to be part of the game. So this is a bit secret information because in a couple of weeks, actually in 2 weeks, we're launching, it's not 2 weeks, oh gosh. Next week, we're launching Iris Broadcast. There's no website yet, I'm sorry, working there. But it's coming soon to an internet near you. And the reason the Swedish Radio is doing this, well, we want to share the work we've done. We want to make our implementations, reference implementations for people to experiment with. And we want to create an open platform for all the public radio broadcast people and the industry to share knowledge, to run tests, and contribute. So it's going to be a series of small pieces of software and large pieces. We're bringing out the CCM, the codec call monitor, into open source. And this is something that's been in development for many years internally. So we're working now with license reviews, code reviews. Documentation review was easy because there was almost none. So we're trying to fix that. We're working with lawyers on licensing, which is interesting. And at some time later this year, we're going to publish everything open source. It's a time-consuming process. Much easier to join an existing project like Kamailio when everything's been done. But it's fun. May 19th in Stockholm, we have a conference called Broadcast Radio Revolution or Evolution. We fill the conference with people from all over Europe, public radios around Europe, as well as the industry, all the vendors we have. We're in a large studio, one of the largest in Sweden, and we're going to launch the open source project then. And I feel this is just the beginning. Open standards, open source, making things commodities. Well, we've seen it before, as I said in the beginning. We've seen it in many different industries. It's now hitting the radio big time. The number of Raspberry Pis, the numbers of open source engineers we have is rising, and it's really great. Here's where you can find us today. The website isn't up, but the rest of the stuff is there. So feel free to follow and see what's happening. If you're consultants, why don't you contact your national radio station and say, well, we know in Sweden they're using Kamailio. I can help you with Kamailio for a professional radio broadcast. It will be fun, I promise you. So that's my talk about Kamailio on air, doing cool things. But I can't leave you there, right? I will get complaints unless I tell you what to do the coming year. So this is your to-do list. You need more crypto in all your calls, media and signaling. Of course, you need 128 bits of happiness, IPv6. You need to get alive, you need to tell a story. Thank you very much. See you next year at Kamailio World.
Questions? Okay, one there, one back. One moment. First here and then Fred.
Hello. One question. Do you happy with existing Kamailio modules, or you have to implement something especially for your solution, or just routing config file and that's it?
Well, we have all the standard Kamailio modules. But if you go back to my commits during the last couple of years, you'll see some stuff that we needed, but we contributed that back to Kamailio. For instance, the HTTP client module was a necessity for us to do the proper things and throw away some Python scripts that didn't work properly.
What kind of power issues have you had with a portable backpack and things like that? What kind of power issues have you had to overcome?
You know, radio waves contain a lot of energy. We can harvest that. For more answers, I may need a cookie. No, we have a big battery backpack in there that can actually sustain the equipment for hours. But we can't take more than I mean, the backpack is for smaller projects on the town. For larger projects, we have the car and other things with more energy. Any other question?
How many steps a day?
Hi, Olle. Sorry if this was on a slide and I didn't see it. What's the backhaul from the backpack to the matrix?
Oh, to the matrix. You will be assimilated, David. We have a vendor solution today where we have multiple SIM cards and duplicate traffic over many SIM cards. It's basically a mobile VPN, but everything is going on multiple cards all the time. And we take the traffic back in our offices and aggregate it into one single stream. This is a multi-SIM solution. And it went really, really on hard testing during the terror attack in Stockholm in the beginning of April. But we always had working networks. Even though most of the mobile networks got overloaded, we could have live radio broadcasts from downtown Stockholm, which was amazing.
Okay, thank you, Olle. Thank you for
You're welcome.
everything.